So right now we know all of this info. When I go into this next step, one of the quick things that I'm going to do to make it a little bit easier, does everybody see that 2b, 6g, 150, are they all even? I'm going to go ahead and simplify that out right away. That's always a good idea to do if it's possible. So I know that it's b plus 3g is less than or equal to 75. The only reason why I'm doing that is because when I do my intercepts for it anyway, I'm going to be simplifying those statements. It makes it easier to find the intercept of both of them. Because now by setting that up as b plus 3g, do you see how we'll use substitution to find the intersection of them? It's easier than doing a combination of 2's and 5's, 6's, and 4's. It's just a little trick. If you do it, great. If you don't, not the end of the world. I've got the other example, the farmer one at the end. You could do that as well. You can divide them out by like 6's and 4's or something. When I set this up, I've got my B and my G. Just going by letters. First one. I know my intercepts, 75 and 25 for the first equation. And it's working inward. Okay? For the second equation, I have intercepts of 31 and 38 and 3/4. And it's also working inward. So I'm at this parameter, that four-sided figure. Now I have to find out where this point occurred. In order to figure out where that point occurred, it's the intersection of the two lines. It's the intersection of these two lines. I'm going to use system of equations via substitution to solve. So I know that B equals 75 minus 3G. Do you agree? Substitute in 5 times 75 minus 3G plus 4G is 155. 375 minus 11G is 155. You wind it with G, or I mean to go, G is 20. Just moving everything around. Now the value of G is my y coordinate. Do you agree? So to figure out the x coordinate, B plus 3 times 20, B plus 60 is 75. What's B? 15. Excellent. So those are the 4 points I checked. I'm going to check 0, 0, 31, 0, 15, 20, and 0, 25. That'll help me find my maximum and my minimum. In this case, I think we just had to find the maximum. And you should find the maximum at the 15 and 20, if I'm not mistaken. Okay? Yes? You should get the exact same result. In that case, your ordered pair would have been 2015, but that means as long as you're consistent, it's fine. It'll work. It'll work out. Yeah, Richard. And this comes up, this comes up from time to time. In some of these cases, you really don't need a graph. Because some of your parameters are such that you can get away without it. But don't rely upon that. Because when you get into the next couple of problems, like the machine one, definitely, you can't just fudge your way through it. All right? Yes, sir?
I just like graph the hours, and then I don't think that it intercepted at 15 and 20, but I still got the same shape as that, and then I just did the whatever I don't know how to explain it. Whatever that one thing is called when you make the x equal to x and then you
Substitute in?
Yes.
Yeah.
I did that in round 15 and 22.
And once again, it's such a way, when you only have two of the equations, not three, and there's not that extra line thrown in there, and your parameters are all working towards 0, it kind of allows you a little more leeway in how you set it up. So you can get away with that. It works. It'll work.
All right.
You just be careful if it doesn't look that way. Hey, let's do a proof. It's a joke. Don't worry. I had geometry last hour, so I'm just trying to get the right stuff up. I don't know. I think that the machine one is more difficult than the farming one.
Yes.
I'm going to walk through the farming one because it's a little bit easier. What's that? Oh yeah, the farming one was, of all of them, the only thing about the farming one is that it's a longer read. But once you get through once you read out the whole problem, it's fairly straightforward. It mirrors the one we just did. So, as we start out by reading out all of this mumbo jumbo, you know you're talking about expenses, you know you're talking about storage capacity, and you know that's asking you to maximize profit. So, as you read out the whole story of this, the goal is to maximize the profit. You're maximizing the profit of corn and soybeans. So you have a certain amount of corn plus a certain amount of beans to maximize your profit. You make 24 bucks an acre and 48 bucks an acre as far as profit is concerned. Also, you know that you have $2,400 to spend on seeds, and you have 3,600 bushels of storage space. So those are your two other parameters, $2,400 and 3,600 for the storage. Now, corn cost $6, beans were 12 bucks, and storage-wise it was 12 and 16 respectively. Okay? Just pulling that information straight out of there. And you have negative amount of corns and beans. Nope. So your first quadrant again. Now, once again, when I set this problem up, everybody see how it's 6, 12, and 24? What can I divide those all by? 6. That's fine, and that's okay. Really, it's okay. Because the only reason why I'm doing this, to simplify these out, it's the same thing as saying C plus 2B is 400. And then if I divide this one all by 4, I get 3C plus 4B is 900. The only reason that I'm doing that is because I know that when I solve my system, it's going to be easier to use substitution than what you do with your linear combination. You hopefully are going to get the same result as me, but you just did a little bit more work. And I am very proud that you figured out the fraction. Seriously, that's awesome. Most people would have said, but that's great. That is huge. That's really, really something to be proud of that you did the fraction there. You give them a pat on the back. I know you're dying to. So, but the only other reason why I'm simplifying out the two inequalities is because when I cover and solve, I'm going to be getting the same result. You got to divide out. So why not make it easier on yourselves? Corn and beans. When you do your intercepts, you have 400 and 200 respective. Oh, sorry. And they're working inward. Um, 300 and 225. Working inward. I gotta find that intersection. That intersection is gonna occur C equals 400 minus 2b. $1,200 minus 6b plus 4b, which is 900. Moving things around, I get 300 is 2b, or not 2b. I have to figure out where these two lines intersected, okay?
I did that, but I found out where they intersected, but I didn't do whatever.
I'm using substitution to figure it out instead of doing some linear combination.
But
You-
you could still use those two equations.
Yeah.
I'm just talking about two together.
Absolutely. You're going to get the same answer. This way it's just faster. That's all. So I get 150 for b. That's the y value. 2 times 150 is how much? 400 minus 300 is?
100. Oh, I was going down.
You were that close. Your ordered pairs then.
Oh, so one line is a expense line.
Mm-hmm.
Another line is a storage line.
Yep.
And then wherever they intersect, that's
The break even.
break even.
Those are my ordered pairs. When you put that into your cost or your constraint, or excuse me, objective, it's one of those, you're not going to make any money if you don't plant anything. The 300, you wind up making $7,200. This one you make $9,600, as well as this one. And like I was saying yesterday, with linear combinations, depending upon objective functions and some of the parameters, it is completely, totally feasible to wind up with 2 correct answers, and that's fine. It doesn't happen very often, but it is completely reasonable to occur. So they could either plant 200 bushels of beans or 100 bushels of corn and 150 bushels of beans to make the same amount of money. I think it would be easier to plant all the same type. That way you don't have to change things and do stuff. I would imagine it would be less work. I don't know, I'm not a farmer. But then again, I also had a student third hour who told me that her father looked at those numbers and said, no, they're not $6 an acre, they're 500. He made her rework the problem with the proper figures. I think it's awesome. That's like the greatest dad ever. And it still came out that I'm not going to tell you. You can watch the video and figure out who we were talking to. Richie, and I'll get you next.
I got the second right away.
What?
How do you get
That's
zero
if
to
there's
100?
2.
How do you know that?
This one money.
This is because when we drew this one out, it was moving inward.
But like, where's your equation? I just don't know where it is.
It's the y-intercept, so it's 0, comma 200. That's why. Okay, same thing with the other one. It's 300, comma 0 for the x. Yes, ma'am.
Can you explain how you got the objective?
In the problem, it's stated, it asked you the following question. It said, suppose the farmer earns $24 for each acre of corn, 48 for each of the soybeans.
Oh, okay.
Find 2 ways a farmer can maximize the profits.
All right, nice.
It'll tell you, maximize this, maximize that. It was just, it happened to be in the
Sorry,
grade.
I got like everything else. I think I just did one.
The ones we do tonight, I think the first question that I give you tonight, it's in the first sentence what to do. Yes, ma'am?
Okay, so I have my x's and my y's switched around when I graphed it, and somehow I didn't get the same answer.
What happens sometimes if you flip-flop them around, if your objective function didn't have them flipped, then it's going to give you an incorrect value. Does your objective function correspond to what you were looking at graphing? What's your objective function?
24c plus 40x equals c.
Okay. Now, that means that when you graph your thing out, did you accidentally flip them into the wrong spot? Into the wrong, when you substitute back in? Because then is your next equation like
wait.
12s plus 6c?
I see what I did wrong now.
Did you flip them?
I think so.
That's usually what people do. That's usually what people do. So remember guys, if you start with your objective function with the first two letters, just keep them consistent all the way through. And think of your first letter as your x, your second letter as your y, you'll be less likely to screw up. And the piece de resistance. Anybody get this one?
No, how do you graph it if there's 4 variables?
It's not 4 variables, there's only 2.
No, there's the machine A, B, and C, and then
No, but it's all time and money spent on each part. If you look at it that way, it doesn't matter if it's A, B, or C. It just matters how much time is spent.
When you have to. He's getting mad, I can see it.
Yeah.
This one is very tricky because it throws in a fourth equation. Not only that, you have to decipher 3 other constraints. So as you're reading through this thing, you have 2 parts, 1 and 2. I'm going to call them x and y just for variable sake because it's a little bit easier. We have part x and part y. Within part x and y, you have 3 machines that you're working with, A, B, and C. Within those, you had specific amount of time that each part used in each machine. In machine A, you used 4, and the next one, let me just keep it in front of me, 4 and 5. The next one was 4 and 1. And the last one was 5 and 6. That's the amount of time each part spent in each of the 3 machines. After that, it told you that you had up to certain amount of time for each machine to be running. When it says you have this amount of time to run, that's always going to wind up being a less than or equal to. You can't run longer than that. So you have less than or equal to 120, less than or equal to 72, less than or equal to 180.
But it has to be greater than 0,
Right,
right?
I'm getting to that one. Yes, sir. No, go ahead.
No, I said the 2. I'm not gonna say.
No, go ahead.
No, I forgot.
Okay. Yes, sir.
What if you added all of those equations together? You know what I mean? Like you added all the x's, added all the y's, and added all the time constraints. That's what I did.
Bless you. Then what'd you do?
I just graphed all the machine time and profit as one big line.
Did it intersect with anything?
Yes.
What? The other line?
It's that's what I got. I don't know.
Yeah.
Yeah.
I added them all together too.
Okay.
But when I did it, when I like graphed and everything, like it did them in separate things, but I only ended up on like 3 points. Like I didn't have 4.
It was an open system. It wasn't a closed system.
It was like a triangle.
Okay.
Yeah.
Huh. I don't know.
'Cause, like,
I'd be curious to see what your answers were when we get down to it.
well, I didn't get the answers. Like,
Oh,
it was
okay.
only 3 points, so I just stopped and thought it was wrong.
The objective of this one was for about profit. You made $8 on this one, and you made $5 on that one, and that's your objective function. The tricky part comes into this problem when it talks about part 2 produced must not be less than half of part 1. Not less than means it has to be greater than or equal to. Do you agree? So that means that part 1, x, half of part 1 has to be less than or equal to part y. That's the tricky one. And obviously everything else is, you can't have anything negatives. When you have this weird one out there, one that's not in that standard form that you can find an x and a y intercept, it's just going through the origin, do not graph that one until you've graphed everything else. And I'll show you why. Got our parameters. When I cover and solve, When I set this problem up, I'm going to switch colors. That way you guys can kind of see which lines are intersecting, because you've got to worry about it. We'll go blue, black, red, and then the last one will be the purple one. Okay? On A, machine A, X and Y, I'm staying true. I'm going to stay true here. X-intercept of 30, Y-intercept of 24. Do we agree? And we're working inward because 0 plus 0 is less than 120. Next one, I have a y-intercept of 72 and an x-intercept of 18. What's black? So 18 is a little bit more than halfway. I'll just put 72 on top. Those two lines intersected right there. So I know I'm going to have to find the intersection point of those two lines. 5 and 6 gives me intercepts at 36 and 30. 36 for x, 30 for y. And that guy intercepts. Now the weird one. Basically it's this. Y equals 1/2 x is what we have to graph. That's the line we're going to graph here. And then we have to figure out what way is it pointing to the shading. Okay? So in order for us to figure out what that's going to look like, we have to walk up 1, right 2, up 1, right 2. But we don't have a scale drawn on our graph to be able to plot out a slope nicely. But what we can do is we can find this intersection point right here and use that ordered pair as a test point to tell whether or not that line's going to go below it or above it. Because that'll give me an x and y coordinate to tell whether it's a true or false statement to know what side it's on. Okay? So let's start with that. The intersection of the blue line and the black line, these two guys. Can I just use subtraction right away?
Yes.
So I have the same value of 4. I wouldn't worry about texting right now because you're not doing well on this. So that's
I'm understanding this part because I have all this.
all right. Well, there's a time and a place. It's neither right now. I'm going to write it out right away. Subtract the 2 out. I'm going to get 4y is 48. You agree? I get 12 for y. So that means my y value at this point is something, comma, 12. I'm going to substitute back into the second equation. 72 minus 12 gives me 60. 60 divided by 4 is 15. Agreed? Right. So now what I'm using is that I'm trying to decide is 15, 12 true or false where this line's going to wind up? Is half of 15 smaller than 12?
Oh, yes.
It's true. So that means that this line would be opening up here, so it would be below that point. You see where I'm going with that? That means that now we have bounded ourselves because the black line, I forgot to draw my arrow, was coming inward here as well. We have just bound ourselves in that 4-sided figure, which means I have to find this coordinate now. Yes, sir?
Couldn't it be on that point? Or well,
In theory, it could, but in this point itself, it doesn't work because 15 is not half of 12. Okay? So that intersection is that purple line, 1/2 x is y, and the black line, 4x plus 1y is 72. I use substitution again with this one here. And you wind up with 4x plus 1/2 y is 72. 4.5x is 72. X is 16. Trying to remember what I did earlier. Yeah. If x is 16, what's y? What's the answer of 16?
8.
8. Now you have your 4 points to check. 0, 0, 16, 8, 15, 12, 0, 24. That's the trickiest as any of these things get, where you've got that extra line coming through that you have to worry about where does it lie within the plane. Yes, sir?
Well, you have to understand that we're bounded within that area. Why can't we just find the points and then understand that this takes the most profit out of this intersection?
Because this point here itself doesn't lie within the shaded region that is holding true within all the 4 parameters. So this point here will not, it may be a maximum for the function, but this maximum doesn't lie within the shaded region that you are bound by your constraints.
So it might take more time that you don't have.
Yes, that's a great example. It would take more time than what you have to do it. So if you were able to add more hours in the day, it's a great idea. But your production is such that you cannot use more than these time frames on the specific machines.
So that's like the possible answers within the constraints.
Right. All possible answers, all these points within this 4-sided figure would hold all of these constraints to being true.
We're
What you-
trying to find the maximum.
Right, and your maximums will occur on your endpoints.
All right.
So now you just substitute into your constraint function, and I think you wind up with 15 and 12 being the maximum. Yeah. All right?
Did you used to have to do this on the whiteboards?
Yeah.
Is that a pain in the butt?
No, it wasn't really a pain in the butt on the whiteboard because, honestly, I like doing these on the whiteboards better because if I got more space. It's easier for me to draw out a real nice big picture here than it is on the board. The reason why I'm making sure I'm using the board solely is because what am I doing? I'm recording. I'm recording it so you can watch it later. If I record this on the board here, you'll hear me talking. See where it goes? It goes right here to the intersection of these 2 lines. What lines is he talking about? That's why I'm trying to use this one. But yeah, whiteboards for this stuff is so much easier to use. More space. Are they less cloudy? Good. Let's try 3 more. Here's what I want us to look at tonight.
Yeah. With you. Yeah, like I can just like, oh, I understand it, like,
Yeah.
like doing it, like I
Yeah,
can
but when you
follow
get
along.
home,
What I,
everything.
yeah,
like, I
but I
can't
just can't do it for
You're
myself.
not in math mode anymore.
Your body shuts down. It's a metaphor.
No, I know. Yeah.
You're gonna use one, like, you just did.
There is one that we're going to look at tonight that is similar in scope, that you have that weird non-standard form equation, but it's not as messy. Okay. What I want us to do tonight is on page 167, I believe.
Why are the books word problems so bad? Like, it's like filing cabinets, home canning.
And
Choose
oversaturated.
one.
It's tough to find good ones like this. The filing cabinet problem of these 3, let me write this up first. What I want you to do is on page 167, it's still section 3.4. I want you to do the problems in this order. 22, 21, and then 23. The reason why I want you to do those in that order, 22 is a piece of cake. 22 right now you guys should be able to look at and say that you can set that up without too much of a hassle and go for it. 21, there's one extra step that you have to worry about. They talk about a conversion. In number 21, they're talking about things in quarts and then things in gallons.
4 quarts in a gallon.
4 quarts and a gallon. Make sure you put everything in terms of quarts in 21. That's the kind of the trick. And once you get everything in terms of quarts in number 21, you should be okay. 23 also is very straightforward, but there's that extra line. It says I think you have to be, one of them uses 3 times as much as the other. So you have to worry about that extra line. So plot that line last. So with these 3 problems, I'm going to do like I have with every other class so far today. Start you off on 22. And one of the things that we've kind of done a couple of times today is as you start in these problems, as you read it real quick, office manager's purchasing file cabinets and wants to maximize storage space. What's your objective?
Maximize storage space.
Maximize storage space. So you know you need maximum storage.
Is there ever a real life minimum thing you need?
What's the fewest amount of these you need to use to build something? Yeah, you can do that. So you want to maximize your storage. So you know you have 2 cabinets. The next thing he says, you have office space of 60 square feet, and you have $600 in the budget. What do you think your 2 constraints are going to be?
Space and money.
Space and money. Good. So space and money. How much space do you have?
60 square feet.
You know it has to be less than or equal to 60 square feet. How much money do you have?
$600.
Correct. So far, just by reading that out, we know these 2 things. Now it says you have cabinet A and cabinet B. So you're working with cabinet A and B. And for each one of these things, they have some value. Well, cabinet A requires 3 square feet of floor space, storage capacity of 12 cubic feet, and costs 75. Which one of these does the 3 go in? Max storage, space, or money? Space. The max storage is when they're talking about has storage capacity. That one goes here. And how much did it cost? You're on your way. Can you have negatives? No. Use that same principle when you're setting these things up. If you can, if you have to, make yourself a little table and work your way through it.
I am going to announce sections of the building to start filling the gym for Mr. Mojo. Teachers are asked to walk down with their students and have them fill the stands starting at the top. There will be 7 classes that will be seated on the gym floor. Please follow the directions of the dean, the security, and counselors to fill the bleachers.
I think it's supposed to go
At
right
this
there.
time, I would like to announce for the first floor west and the first floor north to start heading towards the gym.